Hi everybody, and once again welcome to Pankaj Sir's Echelon Tutorials. And in this today's session, we are going to deal with the ISC curriculum, and the 11th grade is the level, and subject is still the physics, and the topic is units and measurement. Okay, now this is chapter number 2 from the book that I refer to, and the book that I refer to is book by Kumar and Mittal. Okay. So to start with, in this chapter on units and measurement, okay, that is chapter number 2, we are going to deal with physical quantities, the units, the measurements, and other things. Okay, so let us get started with. So first of all, let us understand what is physical quantity. On the screen, you can see that physical quantity already I have defined as a quantity linked to a physical phenomenon and which is measurable is called a physical quantity. So any physical quantity is something which should be measurable, very important, and it should be linked to some physical phenomenon. Okay. For example, uh, intensity of a light is a physical quantity. Moment of inertia is a physical quantity. Acceleration is a physical quantity. Force is a physical quantity. So there are n number of physical quantities. All these physical quantities are related to some or other physical phenomenon, and these physical quantities are all measurable. Okay, so the definition for physical quantity is this. What is the definition of unit? Let us see what is unit. Now, a standard magnitude used to measure a physical quantity is called its unit. So once you know that you have something called physical quantity, then you should have some standard magnitude which should be used to measure that physical quantity. For example, suppose mass is a physical quantity, and to measure the mass, if you want some standard magnitude, then kilogram can be considered as a standard magnitude, or gram can be considered as a standard magnitude. Okay, so these are standard magnitudes. By standard magnitude, what I mean is any bigger quantity can be multiplied by the standard magnitude. Okay, so it can be compared to the standard magnitude, right? So standard magnitude is the base or the basic magnitude of any physical quantity. That standard magnitude is known as the unit. Okay. Now, what is measurement? Measurement is a comparison of a given physical quantity with its unit is called measurement of that physical quantity. So measurement is what? Measurement is nothing but the comparison of the given physical quantities. Now, whatever physical quantity is given or that is in front of you, that you have to compare with the unit. Okay, what is unit? Unit is the standard magnitude. So whenever the comparison is made with a standard magnitude, then the unit is multiplied by that quantity, and that is how you measure the physical quantity. It can be expressed with the help of two things. Now this measurement can be expressed in with the help of two things. Two things are essential, important in any measurement. The first is unit and the second is numerical value. Numerical value is many times also known as magnitude. Okay, so I'll give you some example to understand this. Suppose you have a rod which is 10-meter long. Okay, so uh, in this statement, what I'm trying to say is you have a rod whose measurement has been taken, and the measurement is written as 20-meter. Now this 20-meter is nothing but the measurement. Now this 20-meter consists of two parts essentially. One is the 20, which is the numerical value, or you can say the magnitude. And second part is the meter, which is the unit. Okay. So when the magnitude and unit combine together, then a measurement is complete. So 20 meters ka rod means in that particular measurement, 20 is the magnitude and meter is the unit. Now, this 20-meter rod can also be expressed as 2000 centimeter long rod. Okay, nothing wrong in that, because 20 meter and 2000 centimeter is one and the same, right? So when you say that the rod is 2000 centimeter long, what is the unit? The unit is centimeter, and what is the magnitude? 2000. So now you see that the unit has changed from meter to centimeter, and the magnitude has changed from 20 to 2000. But the length of the rod is still the same. Now let us express the same length of the rod in millimeter. So in millimeter, you will say that it is 20,000 millimeter long rod. Okay. So when you say that a rod is 20,000 millimeter long, what it means is the measurement says that 20,000 is the magnitude part of that measurement and the unit is millimeter. Okay. So 20,000, that is the magnitude, and millimeter, which is the unit, they both combine to tell you the measurement of the rod. Okay. Now again you can see that the unit has been changed from centimeter to millimeter, and the magnitude has also increased from 2000 to 20,000. Here we say that the unit meter is a bigger unit compared to centimeter, and centimeter is still bigger unit compared to millimeter. So you can say that in the order of increasing order, millimeter, okay, is less than centimeter, less than meter. Okay. So this is the order of the unit. Or you can say millimeter is a smaller unit compared to centimeter, and centimeter is again smaller unit compared to meter. Okay. Now if the length remains the same, you can see that when the unit is increasing, the magnitude is decreasing. Okay. Or the other way, when the unit is decreasing, okay, when the unit is becoming smaller and smaller, the magnitude is becoming bigger and bigger. Okay. So here you can see that meter is a bigger unit, but then the corresponding magnitude is smaller. Now when the unit has decreased, okay, it has become smaller. From meter it has come to centimeter. So when the unit is decreasing, what is happening to the magnitude? It is increasing. From 20 it has become 20,000. Again from centimeter, the unit has decreased to millimeter. Okay, so millimeter is still a smaller unit. So whenever the unit becomes smaller, the magnitude becomes bigger. The magnitude now has become from 2000 to 20,000, isn't it? So here in this example, you can see that as the the unit goes on decreasing, what is happening to the magnitude? The magnitude is increasing. Magnitude is increasing from 20 to how much? 2000, and then to 20,000. Okay. So this is what is happening to the unit, and this is what is happening to the magnitude. So a general statement can be made that the unit and the magnitude are inversely proportional to each other, because as the unit is decreasing, the magnitude is increasing. Therefore, you can say that the magnitude is inversely proportional to the unit. Now, this is a very important statement, or this is a very important thing in physics that you should understand. Okay. So magnitude of any physical quantity is inversely proportional to the unit. The meaning of this is, as the unit decreases, the magnitude will be increasing. Okay. Now, meter is a bigger unit than the centimeter, and centimeter is a bigger unit than the millimeter. Okay. Now, this particular thing, magnitude is inversely proportional to unit. This can be written as magnitude is equal to some constant divided by unit. And this can be written as magnitude multiplied by this unit will give you some constant k. Okay. So you get another big statement that magnitude multiplied by unit will always be constant. So can you see this statement you are getting? Magnitude multiplied by unit will always be constant. Okay. Now let us try to write this in a very simple form. Suppose if n1 and n2 are the magnitudes of a physical quantity, n1 and n2 are two different magnitudes of a physical quantity, and u1 and u2 are the units, then N1U1, that is the product of the magnitude and the unit, will be equal to the product of the magnitude in some other system and the uh, uh, and its unit. Okay, so N1U1 is equal to N2U2. This is very important statement, right? Now coming to some fundamental quantities and fundamental units. Now you know that in physics, the very fundamental quantities, very fundamental quantities are length, mass, and time. All other quantities, all other physical quantities are basically a combination of these fundamental quantities, or you can say they are derived from these fundamental quantities. Okay. So what are the fundamental quantities? Fundamental quantities are length, mass, and time. Okay, now corresponding to these fundamental quantities, you have certain fundamental units, the standard measuring unit or the standard measurement. Okay, now along with these units, you have certain system. Now basically there are many systems were being followed initially. Like for example, initially you used to have CGS system, you used to have FPS system, MKS system. Then now you have something called SI system. So there were various systems which were used by people around the world. CGS system stands for centimeter gram second. Okay, so in CGS system, the mass is measured in gram, the length is measured in centimeter, and the time is measured in seconds. In FPS system ka full form is foot, pound, second system. What is it? Foot, pound, second system. In this system, the mass is measured in pounds, the length is measured in foot, and the time is measured in seconds. Okay, so there was this system also being used in the past, FPS system. Then there was something called MKS system. In MKS system, the mass was measured in kilogram, that is the unit of mass was kilogram. The unit of length was meter. The unit of time was second. And in MKS system, one more fundamental unit was included, fundamental quantity was included, and that physical quantity was current. In MKS system, instead of 3, you have 4 physical quantities, the fourth one being current. And the unit of current was ampere. So that was MKS system. But recently now, a single system has been accepted throughout the world by everybody, and that is known as the SI system. SI system is System International D Units. Okay, this was established in 1960, and since 1960, this is the system which is accepted by everybody universally throughout the world by each and every country. Okay, so in 1960 it was established, and till date it is working. In this SI system, you have some 7 basic units and you have some 2 supplementary units. Okay, fundamental units are 7 and there are some 2 supplementary units also. So let us talk about that. Now before I come to the fundamental units and all that, okay, length, as I told you, has in CGS system, it is measured in centimeter. In SI system, it is measured in meter. Mass is measured in grams in CGS system, and it is measured in kg in SI system. Okay. In SI system, mass is measured in kg. Time is measured in all systems in second only. Okay. In CGS system, it is measured in second. In SI system also, it is measured in second. Now, fundamental units are independent of each other. That is, they cannot be changed or they cannot be related to one another. So that is why they are known as fundamental units. So what are the fundamental units? This gram, centimeter, second, or you can say kilogram, meter, seconds, ampere, foot, pound. All these are fundamental units. These fundamental units cannot be mixed with each other. They are independent of each other. They cannot be combined together. Okay, fine. Now coming to SI units, which is universally accepted since 1960. So in this, as I told you, there are 7 basic units. So the 7 basic units are meter for measuring length, kilogram for measuring mass, second for measuring time, ampere for measuring current, Kelvin for measuring temperature, mole for measuring amount of substance, and the CD stands for candida. Okay, that is a unit for luminous intensity. Okay, so this length, mass, time, current, all these are physical quantities, and meter, kg, second, ampere, Kelvin, mole, all these are units. Okay, so these are the 7 basic SI units, 7 basic SI units. Okay, and these are the 7 basic SI quantities. Okay, so the 7 quantities and the 7 units in SI system are listed over here. Now, as I told you, in SI system, you have 2 extra supplementary units. You have what? You have 2 extra supplementary units. Now, what are these 2 extra supplementary units? They are radians and steradian. Radians and steradian are 2 supplementary SI units. Okay. Now, if these are units, then the corresponding, there should be some physical quantity. So, 2 supplementary physical quantities, okay, in SI system are this, something called plane angle and solid angle. Okay. So, plane angle and solid angle are 2 supplementary units in the 2 supplementary physical quantities. These are the 2 physical quantities in the SI system, and the corresponding units of these physical quantities, that is the unit for plane angle is radians and the unit for solid angle is steradian. Okay, steradian is in short written as SR and radians in short is written as RAD. So that is about the SI system with 7 basic units and 2 supplementary units. And I'll explain you with what are the physical quantities and what are the corresponding units in the SI system. Now, once you have understood these systems, that is SI system, CGS system, MKS system, etc., you don't have to worry much about other systems. Now only one system is being followed, which is SI system. But in this SI system, you have some 7 basic physical quantities and the corresponding 7 basic SI units also you have. See, there are many other physical quantities, but those physical quantities in SI system will be derived physical quantities. They will be a combination of these, basic physical quantities. And again, there will be other SI system. There will be other units also, but those will be derived units. Okay, so derived physical quantities will have units which will be a combination of the basic units, or you can say the fundamental units. Okay, so that is how fundamental and derived quantities is something you can relate to, and that is how the fundamental units and the derived units can be related to each other. Okay, so once you have discussed about this SI system, once you have discussed about the physical quantities and the units, okay, now we are going to talk about the SI units, okay, SI units of length in detail. Okay, so SI units, as I told you, SI system, SI is a system. In this system, you have 7 fundamental quantities. Okay, so which are the 7 fundamental quantities? As I told you, length, mass, time, current, temperature, amount of substance, luminous intensity. These are the 7 fundamental physical quantities in SI system. Out of these 7, we are going to take the first one, that is the length. So length is the first physical fundamental quantity of the SI system that we are going to discuss. Okay. So length is a physical quantity in SI system, and this length, the standard unit, I told you what is unit. Unit is a standard measurement. The standard measurement is taken as meter. Okay. So for measuring the length in SI system, for measuring the length, the standard measurement is 1 meter. So this is the standard measurement. Okay. This is the standard measurement. 1 meter, or meter you can say. This is denoted by M, right? Now, there are certain lengths which are much bigger than the meter, and there are certain lengths which are much smaller than the meter. Okay. So, length can be more than the meter, bigger than the meter, and length can be smaller than the meter. What I want to say is the units of measurement can be bigger than meter, and then there can be units which are smaller than meter. I'll give you some example. Kilometer is a unit which is bigger than meter, right? Centimeter is a unit which is smaller than meter, right? Same way, miles is again a unit of length. This is greater than the meter, and millimeter is something which is smaller than the meter. So there are lot many units which are bigger than meter, and there are lot many units which are smaller than meter. Okay. So here I have listed down some of the units which are bigger than meter. So bigger than meter is, the first one is kilometer. So what is 1 kilometer? 1 kilometer is 1,000 meters. So uh, when you collect, or when you add 1,000 meters, when you take 1,000 meters, that collectively 1,000 meter distance, 1,000 meter ka length is known as 1 kilometer. Or you can say in 1 kilometer there is 1,000 meters. So 1 kilometer is a bigger unit compared to meter, because in 1 kilometer you have 1,000 meters, right? The magnitude, here you can see 1 kilometer, and this is 1,000 meter. Now you can see that the magnitude here is more. Okay. So where the magnitude is more, that particular unit is smaller. So 1,000 is bigger than 1. Therefore, meter is something which is smaller than the kilometer. Okay. This is how we have to connect. So meter is smaller than kilometer, because the magnitude in the relationship is 1,000, which is greater than 1. Okay. So when the magnitude increases, the unit is becoming smaller. Okay. This way you can understand that kilometer is a bigger unit compared to meter. Centimeter is smaller unit compared to meter, because 100 centimeter is equal to 1 meter. Now can you see, this is 100 and this is 1. So which side the magnitude is bigger? Here the magnitude is bigger. So this unit will be smaller than this unit. So that is why we say that centimeter is a smaller unit than meter. Okay. Now millimeter and meter, again you can do it the same way. Okay. So let us now talk about some units which are bigger than meter. So 1 kilometer is a unit which is bigger than meter. Then you have one astronomical unit. Okay, AU is full form for AU ka full form is astronomical unit. Now this is still bigger than kilometer. Astronomical unit is bigger than kilometer. One astronomical unit is equivalent to 1.5 into 10 raised to 11 meters. Okay, it is equal to 1.5 into 10 raised to 11 meter, right? Then you have something called light year. Now light year is still a unit bigger than the astronomical unit. Okay, light year is still bigger than astronomical unit. One light year is approximately equivalent to 10 raised to 16 meter. Okay, 1 light year is equivalent to 10 raised to 16 meter. And you have a unit called 1 parsec. PARSEC. It is denoted by a symbol PC. Okay, small PC. So 1 parsec is equivalent to 3.1 into 10 raised to 16 meter. Okay. Now this 1 parsec is the biggest. This 1 parsec is the biggest unit of length. You don't have any unit bigger than this 1 parsec, or rather parsec. Okay. You don't have any unit bigger than the parsec because you don't need. Parsec is a unit which is used for measuring huge distances, say distance of a nearby star from the Earth, or you can say planet from the Earth, or you can say moon from the Earth, or Jupiter from the Earth. Okay, so these huge distances are measured in terms of parsec. So parsec is the biggest unit of length. Now let us come to the smaller units. Smaller units than meter. So smaller than meter is centimeter. Smaller than centimeter is millimeter. Smaller than millimeter is something called micrometer. This is micrometer. Okay. And then you have something called nanometer. Then you have Armstrong. This is Armstrong unit. Okay. 1 Armstrong is 10 raised to minus 10 meter. Okay, nanometer is 1 nanometer is 10 raised to minus 9 meter. This 1 micrometer is 10 raised to minus 6 meter. Okay, so this way the smaller units of meter, smaller units, smaller than meter, there are so many units. Okay, then you have something called 1x, which is equal to 10 raised to minus 13 meter, and you have something called 1 fm. This is the smallest unit. Okay, इससे छोटा unit is not there because we don't need. 1 fm is 10 raised to minus 15 meter. In other words, if you take 1 meter and if you divide it into 15, 10 raised to 15 equal parts, from that if you take one part, that small part is nothing but 1 fm. Is that clear? And 1 light year, you can understand this way. 1 light year is equal to the speed of the light multiplied by the time. Speed of the light multiplied by time. Okay. So 1 light year is how much? It is speed of the light is 3 into 10 raised to 8 meter per second. This is the speed of the light. Multiplied by time. Time in 1 year. Okay. So in 1 year, how many seconds are there? So in 1 year, there are 365 days. Okay, in 1 day there is 24 hours. In 1 hour there is 60 minutes, and in 1 minute there is 60 seconds. So if you multiply out this 365 into 24 into 60 into 60, you will get this quantity in seconds. Okay, so the time in seconds multiplied by speed in meter per second will give you 1 light year. So if you multiply 3 into 10 raised to 8 by 365 into 24 into 60 into 60, you will come across this answer, which is equal to 9.5 into 10 raised to 15 meters. This distance is known as 1 light year. This is known as 1 light year. So 1 light year, the definition of 1 light year is the distance traveled by the light in 1 year is said to be 1 light year. What is the definition? The distance traveled by the light in 1 year is said to be 1 light year, and that distance in meter works out to 9.5 into 10 raised to 15 meters. So these are all the numbers, okay, which you should try to understand, because now you are going into higher physics, and you can see when you are going into higher physics, when you want to understand physics, there's a lot of mathematics that you will have to understand, that you should know to support you. Okay, so slowly, steadily, you will see that mathematics and physics both are going hand in hand together, and both are nothing but the two pillars, main pillars of engineering. So to understand physics in totality, you should take support of maths, and to understand maths, there should be some physics that you should come to know. Okay, and I'm sorry for interruption. My roomie pet is with me, and anyways, okay, fine. So let us continue. That was about the units of length. Now light year and parsec are bigger units of length or distance. Okay, lighter and parsec are bigger units of length or distance. Now this part of the video, or the session, I'll be continuing next time, because I think now the time doesn't permit me. So from here I'll be continuing in the next video. That's all for today, and thank you for being with me, and please try to subscribe my channel to motivate me to make more and more videos for you people. And thank you for being with me. Bye. Take care, all of you. See you in the next video.